Now, for a long time, when it comes to the question of sodium and ME-CFS, the main problem was thought to be that the ME-CFS body was losing too much sodium. And this indeed is happening. And yet recent research has also shown that in some other parts of the body, the ME-CFS patient is actually gaining sodium. So what can actually explain this seemingly paradoxical situation? In this video, we're going to break it all down. First, my name is Patrick Usher, and I'm author of the book Understanding ME-CFS and Strategies for Healing, in which I talk about some of the latest breakthrough research into ME-CFS and long COVID, as well as the various treatment strategies that I have tried in order to improve my condition. Links for that book are down below. So what we're going to do in this video is I'm going to talk about each problem separately, the tendency to lose sodium and also the tendency to gain it, describe why and how these things are happening, and then at the end we're going to consider why both of these problems occurring simultaneously is not as paradoxical as it might actually seem at first glance, and actually makes a lot of sense in light of the pathophysiology of ME-CFS. So first of all, this tendency to lose sodium and to lose salt in ME-CFS. Now, this is a long established problem in the illness, and it is the primary reason for why the ME-CFS patient develops hypovolemia, or low blood volume. Now, it's not the only reason, but it is the main one. And it comes about because the hormonal network which controls salt retention, the renin-angiotensin-aldosterone system, has become dysfunctional in ME-CFS. So these are all hormones, renin, angiotensin, angiotensin 2, aldosterone, which normally work together to instruct the kidneys to retain salt. And in situations where the healthy person is suddenly faced with kind of losing salt, for example, they're sweating out a lot of electrolytes, this hormonal network will actually increase its activity very significantly in order to hold on to the salt that the body has. The problem in ME-CFS is that this is not happening. The activity of this hormonal network has been reduced, and so this means that when the ME-CFS patient goes to the toilet, they are peeing out more sodium than they would otherwise. Over time, this then leads to a reduction in blood volume, and because the hormonal network that controls salt retention is suppressed, then you can't really get the blood volume back up because the means to do that are not there. Now, it's my own personal feeling that the peeing out of salt in ME-CFS particularly occurs during post-exertional malaise, although that has not been approved yet in the study. However, I may do a video sometime on why I think that. Similarly, I might also do a video sometime on why this renin-angiotensin-aldosterone system suppression is probably occurring in the first place. Because let's face it, it's a bit strange. I mean, the body is supposed to be able to hold on to salt. Why is it not able to do this in ME-CFS? But it's actually a very complex answer, and it would take quite a long video just to explain that. So I'll put that aside for now and simply say this is what is happening. There is this suppression of the renin-angiotensin-aldosterone system. There is this salt loss and the development of low blood volume, and therefore also its maintenance because you can't actually bring the blood volume back up. And so this is what's happening with the first problem in relation to sodium and the fact that in ME-CFS there is the tendency to lose sodium and develop low blood volume. So that problem is all happening in the bloodstream, but simultaneously there is a different problem happening in the muscles of ME-CFS patients. Now, we know this thanks to the work of Professor Klaus Wirth and Professor Carmen Scheibenbogen and their study from 2022, which used MRI technology to measure the sodium concentrations of the muscles of ME-CFS patients. What they found was that after an exercise challenge, which exhausted the calf muscles of a healthy control group and ME-CFS patients, the sodium concentrations within the muscles of the ME patients was almost twice as high as that which was found in the controls. They also found that the sodium concentrations were higher even when these groups were at rest. So there's kind of a baseline increase in sodium concentrations in the muscles. Normally speaking, the body wants to maintain a balance between potassium and sodium concentrations in the muscle cells, which is strongly in favour of potassium. And so this increase of sodium in the muscles speaks to something quite dysfunctional occurring. It speaks to a disturbance of the normal mechanisms that the body has for managing these mineral concentrations at that level. Now, ultimately, this increase of muscle sodium concentration is coming about because of various upstream illness mechanisms. In particular, there is a cell receptor which operates within the muscles called the beta-2 adrenergic cell receptor, which stimulates something called the sodium-potassium pump. And it's the sodium-potassium pump on the cell wall which is normally responsible for maintaining the correct levels of these various minerals. But this dysfunction of the beta-2 adrenergic receptor actually leads to an increase of sodium concentration. Now, that dysfunction of the beta-2 adrenergic receptor is coming about because of autoantibodies, which attach to that receptor and block its normal functioning. And it's also coming about because of desensitization from sympathetic stress that's being driven by the nervous system. And in fact, at this level, we can see a link between the first problem and the second, because when you have low blood volume, your nervous system really freaks out and it releases all these stress chemicals, stress chemical messengers. Those messengers reach the beta-2 adrenergic receptor, and initially they kind of sensitize it, but over time, because there's so many of them, they desensitize the receptor and cause it to work less well, and then we start to get this build-up of the sodium concentrations in the muscles. So this increased sodium concentration is a sign of dysfunction. It's a sign that the muscle cells are not happy, they're not working well. And this will manifest in some very straightforward ways. Basically, high muscle sodium concentrations equals very weak muscles, muscles that fatigue very easily, which cannot activate, which do not have strong force, and which cannot endure being contracted for any significant length of time. This ties in precisely with one of the things that ME-CFS researchers often use in relation to ME-CFS, which is measuring hand grip strength. So it is precisely, I'm sure you've noticed this since you've become ill, that when you try to, hold an object like a kettle with water in it, that actually it feels much heavier than it did before you became ill. The reason for that is the higher muscle sodium concentration. So there you have it. You have these two things occurring at the same time. And although a lot of people initially get very confused about their coexistence, including myself, there's no contradiction here. The one problem is happening in the bloodstream where you are losing sodium, and the other problem is happening in the muscles where you are gaining sodium. In a way, this makes perfect sense because in the healthy person, the pattern is the opposite. In the healthy person, you're able to retain salt in the bloodstream very well, and you're able to keep a lower level of sodium in the muscles very well. So in ME-CFS, where the body's basic processes for how it goes about functioning are kind of breaking down, it makes sense that the pattern would actually be the opposite. And as I said, the problems with losing salt actually end up working into and contributing to the problems increasing salt in the muscles, because the low blood volume stresses out the nervous system, which sends out chemical messengers that reach the beta-2 adrenergic receptors, which then desensitize the receptors and cause those receptors to work less well, which then leads to an increase of salt, or rather sodium concentrations in the muscles. Similarly, the lower anaerobic threshold, as a result of the low blood volume, also leads to increased sodium concentration in the muscles. And would you believe it, and unfortunately it's too complicated to go in here, I'd be talking for 10 minutes about this, but it works the other way too. When you have these increased sodium concentration in the muscles, various different kinds of chemical messengers can get released locally in the muscles that spill over, go to the kidneys, and actually force the kidneys to filter out more salt. So there's this kind of vicious cycle that's going on in every direction in ME-CFS in general, but also with this problem. And for those who are curious, this comes from the work of Professor Klaus Wirth and Professor Carmen Scheibenbogen and their research, which maps out all the interlinking vicious cycles of ME-CFS. But as I say, it's too complicated to go into here. So that's it. you have these two problems occurring simultaneously. This raises a lot of questions. People get very confused about this topic, very understandably, and it's something that I've got confused about and I've had to think about a lot. And I don't know if I have the answer to kind of what we do with this. And, I think it has implications for, what do we do with salt consumption? ME-CFS patients often crave salt. We have low blood volume, and we're often told to eat quite a lot of salt. So the question becomes, if we have a tendency to lose salt in one part of the body, but to gain it in another, if we eat a high salt diet, might we be simultaneously improving one problem and worsening another? This is a question that we don't have an official answer to, but on which I do personally have some thoughts, and I've had to do a lot of experimentation to try and find the right way of going about this for me. And so in the next couple of videos, we're going to explore this topic in more detail. We're going to consider whether a high salt diet is always the best idea in the context of ME-CFS. And I actually believe that it isn't necessarily a good idea, and that it can help one problem while indeed worsening the other. And in this regard, I am very much sharing my own ideas based on my reading of the research and my own personal experimentation. This is not something that's really been talked about. It's not talked about by Wirth and Scheibenbogen, because the classic view is that a high salt diet will not affect muscle sodium concentration. However, more recent research actually suggests that it can. And then in a video after that, we're going to talk about how I actually go about trying to simultaneously boost blood volume while also trying to keep the sodium concentrations in the muscles as low as they can be. That's it for this video. I look forward to your thoughts on it, and I will see you in the next one.